Welcome back, class. In this video, we're going to talk about logarithms. So we're going to learn what logarithms are and how to calculate them. I know that logarithms are often a source of confusion for students, so you may have seen them before, but I'm going to review everything that you need to know about logarithms right here. I'm going to start with this question that doesn't ostensibly involve logarithms, which is, what power of 2 is 32? And so we can just do this just by trial and error. 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, and 2 to the fifth is 32. So that tells me that the answer to the question, what power of 2 is 32, is in fact the fifth power. Now really, this question and questions like it is exactly what logarithms exist to do. And so, in fact, if we were to write this in log notation, this question, what power of 2 is 32, would be written as log base 2 of 32. And the answer that it's the fifth power, we just say this thing is 5. Okay. So this logarithm statement is exactly the same thing as this question and its answer up here. Okay, so just to say that super cleanly in one place, if I write log base b of x, this is really the question, what power of b is x? Okay. And the letter b is used here because this is often called the base of the logarithm. Okay, so I want to do a bunch of examples of figuring out logarithms like this one. So let's start with just the log base 2 of 8. So remember, this is asking what power of 2 is 8. And so if I look up here, I already calculated this. It is the third power of 2 that's 8. So it is 3. And so the log base 2 of 8, it's 3, because 2 cubed is 8. Okay, so here are a few more of these. It'll be really helpful for you if you at this point pause the video, look at each of these, rewrite each of these in terms of what power of blank is blank. So this first one will be what power of 3 is 81, just so you internalize that every time you see log base something of something, you're really rewriting it exactly to what power of b is x, and then you should be able to answer it. Okay, you really should have done these by yourself now, but I'll go ahead and do them. So this, the log base 3 of 81, that's asking what power of 3 is 81. And so if you don't know your powers of 3, 3 to the first is 3, 3 squared is 9, 3 cubed is 27, and 3 to the fourth, that's 81. And so it is the fourth power of 3 that is 81, and so we're going to say 4. For the log base 5 of 25, this is asking what power of 5 is 25? Well, 25 is 5 squared, so that is to say that 25 is the second power of 5. This is 2. And if I want to say why, it's because 5 squared is 25. And it's this power that we're reading off in order to read the logarithm. This would read as the question, what power of 6 is 6? Well, 6 is the first power of 6 because 6 to the 1 is 6. So the log base something of the same something is always going to be 1. And last of the ones I asked you to look at, log base 7 of 1. This is saying 7 to what power is 1? And so I have to think for a second, what powers of things give me 1? And the thing that gives me 1 is when I raise a number to the 0th power. Okay. So what power of 7 is 1? It is the 0th power. Likewise, again, this 7 had no significance. The log base 2 of 1 would also be 0. The log base 100 of 1 would also be 0. Special note, if I try and take the log base b of 0, this is always undefined. Okay. And the reason for this is that no matter what base I choose, for example, 7, there's no power of 7 that's 0. In fact, all the powers of 7 are positive, and so there's no way to get 0 out of this. And so if you try and take log base b of 0 or log base b of some number a, where a is negative, that will also be undefined. So be wary of these. If you try and take a log of 0 or a log of a negative number, you're going to get undefined. And the reason is because you only get positive numbers out of powers. None of that is to say that the logarithm itself cannot be negative. So let's look at the log base 2 of 1/16. This is again asking, what power of 2 is 1/16? So 2 to the what power is 1/16? And I can see, actually, because this is 1 over something, the power here is going to be negative. Because remember, it is negative powers that put things in the denominator. And so, in fact, here it is negative 4, because 2 to the negative 4th power, that'll be 1 over, and then a 2 to the 4th in the denominator, and 2 to the 4th is 16. Okay, so it is the negative 4th power. This is an easy one to get snagged on because you see a 5 and a 25, and it's really easy to say, oh, 5 squared is 25, and move on. But the way I've written this is not actually asking me the log base 5 of 25. In fact, we did that question over back here and saw that that was 2. This is asking a different question. This is actually asking the perhaps less natural question, what power of 25 is 5? Okay, in other words, 25 to the what is 5? And the key observation here is that 5 is actually the square root of 25. And so, in fact, this is a 1/2, because remember, square root corresponds to the 1/2 power. And so the log base 25 of 5, it is 1/2, because 5 is the square root of 25. So always make sure you're reading these in the right order. Last up for this list, let's talk about the log base 27 of 1/3. And so I'll give you a minute again to think about this. So here I'm asking, what power of 27 do I need to take to get 1/3? Like in this earlier example, I definitely need a negative power of 27. So I need 27 to the negative something, because I need to get this thing in the denominator, and it's negative powers that put things in the denominator. But I have to decide, how am I supposed to get a 3 out of 27? And the key thing here is you have to realize that the cube root of 27 is 3. So in other words, the power I need here is actually -1/3. Because remember, the cube root corresponds to the 1/3 power. And so 27 to the -1/3 is 1/3, which is what we're looking for. Now, I should note, so far, it has happened that all of the logarithms we have been writing down have worked out to be rather nice. But most of the time, if you just pick some random numbers, the logarithm is going to be something really ugly. So let me do an example of that, just so that you're comfortable with that. If I take the log base 2 of 10, then I'm asking, what power of 2 is 10? And so I could write down 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16. And actually, what you notice is we just jumped straight over 10, right? As we went from 8 to 16, or as we went from 2 cubed to 2 to the fourth, we went from 8 to 16, passing 10. And so what that means is, I've just shown you actually this logarithm is some number between 3 and 4. So the power I have to raise 2 to in order to get 10 is somewhere between 3 and 4. What is it actually? Well, you need a calculator for that. And so if you go look on your calculator, you'll find that this works out to be 3.32 something something something. Which I'll note is between 3 and 4, as claimed. Now, I'll note at no point on the homework or on the tests am I ever going to ask you to actually type one of these things into your calculator. If you come across a log base 2 of 10 in your answer, you can just leave it as log base 2 of 10. This would be what is called the exact answer, which is a phrase that you'll see show up in the homework packet a lot. This is just an approximate answer. You never have to do this. Okay, so you can leave log base 2 of 10, but if you come across something like a log base 25 of 5 where you actually can calculate it, you should.